Hello everyone, welcome to krishchemistry. A gentle reminder to you all, if you feel that my videos are good enough for your preparation, please subscribe the channel if you haven't subscribed yet, and give your opinion on videos in comment section, and ask any questions if you have, please, on my mail. Okay. These unit conversions and formulas of physical chemistry play a very important role in getting decent ranks in competitive exams. That's why I'm starting this chapter wise unit conversional series, and I'm starting this series with mole concept, because mole concept is the first fundamental chapter of physical chemistry, and I have given my personal notes also in description. You can download that notes from there. Okay. Now coming to the point. Here in the mole concept, the first important formula I have given here is 1 mole equal to Avogadro number of molecules or Avogadro number of particles, that is equal to 6.022 into 10 to the power of 23 particles. Particles means molecules, atoms, ions or anything, right? So 1 mole equal to 6.022 into 10 to the power of 23 particles. This is the first formula. Second, number of moles. We have totally 5 formulas are there on this number of moles. This is the first formula. This is the second formula. This is third. This is fourth. This is fifth. Okay. These 5 formulas are very, very important in mole concept, and I have given these all 5 formulas combinedly again here. Okay. So the first formula here in number of moles equal to number of entities. Entities means again particles. Okay. Number of entities by Avogadro number. Number of entities by Avogadro number. I can write this same formula like this. Number of molecules. Number of molecules are nothing but number of entities. So number of molecules equal to number of moles into Avogadro number. I can write like this. Okay. Next formula. Number of moles again equal to weight by molecular weight, or we can write mass by molar mass. Mass by molar mass. This is another important formula. Again, number of moles equal to PV by RT. This formula you have to use when you have the condition of ideal gas. Okay. If you have the condition of solid or liquid, you don't have to use this. Only if you have the condition of ideal gas in the question, you have to use this formula. Okay. So next formula, again number of moles equal to volume of gas at STP by 22.4. You have to take this volume in liters and this 22.4 obviously liters. Alright. So what is STP? STP is nothing but standard temperature and pressure. What is standard temperature? We know 0 degrees Celsius, that is 273 Kelvin, and this pressure is nothing but your 1 atmospheric pressure. Right? This is 1 atmospheric pressure. Now, number of moles equal to another formula, concentration into volume. Concentration into volume. I can write this concentration equal to number of moles by volume. Okay. So this concentration, I can say molarity. Okay. So I can define molarity here only. So the molarity equal to, I can write equal to number of moles by volume. Molarity is nothing but concentration. Concentration equal to number of moles by volume means molarity equal to number of moles by volume. So molarity equal to number of moles of solute by volume of the solution in liters. This number of moles represents solute, and this volume of the solution you have to take in liters. Okay. Next. So these 5 formulas I have given here again. Okay. C into V equal to weight by molecular weight equal to number of molecules by Avogadro number equal to PV by RT equal to volume of gas at STP by 22.4. Okay, you have to remember this. Now, if I give you one molecule, AXBY molecule, and I'm asking you to calculate how many number of A atoms are there, how many number of B atoms are there, and how many number of total atoms are there. If I ask you like this, can you calculate? Definitely you can calculate. For suppose I'm giving here water molecule. Okay, I'm giving water molecule. How can you calculate this? Just compare this molecule with this water molecule. A is nothing but your hydrogen, X is nothing but your 2, B is nothing but your oxygen, Y is nothing but your 1. Okay, now I'm asking you to calculate number of hydrogen atoms in place of A. How can you calculate? This X is nothing but your 2, right? So 2 into number of molecules. I'm asking you to calculate number of oxygen atoms. Then this Y is nothing but 1, right? So 1 into number of molecules. Total atoms. Total atoms means X plus Y. X plus Y means 2 plus 1, 3. 3 into number of molecules. So you have to calculate like this. Okay. So in order to understand this a little bit clearly, I have given one example here. What is this? Calculate number of atoms in 1.8 grams of water. Examiner given weight of the water, not number of molecules. Examiner didn't give number of molecules here. You have to calculate number of molecules from this weight. How can you calculate? First of all, you have to calculate number of moles. How can you calculate number of moles? We have one formula here. Number of moles equal to weight by molecular weight. Number of moles equal to weight by molecular weight. You have to calculate number of moles equal to weight 1.8 grams by 18. We will get here 0.1. 0.1 here. So this 0.1 is number of moles. Then how can you get number of molecules? Number of moles into Avogadro number. This formula. Number of moles into Avogadro number equal to number of molecules. So 0.1 into Na. 0.1 Na. So this is the number of molecules. I have this many number of molecules. Now, if I ask you to calculate how many number of hydrogen atoms, what you have to do? How many number of hydrogen atoms? Simple. 2 into 0.1 Na. 2 into 0.1 Na. Okay. How many number of oxygen atoms? One oxygen atom only. So 1 into 0.1 Na. Total number of atoms 2 plus 1 3. 3 into 0.1 Na. Okay. You have to calculate like this. Okay. By using these formulas. Next. Very important data. Again, boiling point of water. Melting point of water 0 degrees Celsius, that is 273 Kelvin. Boiling point of water 100 degrees Celsius, 373 Kelvin. Density of water 1 gram per ml. This data will be very useful in dealing the questions. When you deal the questions, when you deal with the questions, this data is very, very useful. Okay, you have to remember. Next, molarity I have discussed already, right? Here this is molality. What is molality? Number of moles of solute by mass of the solvent in kg. Okay. Next, normality. Number of gram equivalent of solute. Number of gram equivalent of solute upon volume of the solution in liters. Okay. Again, this units also important. 1 liter equal to 1 decimeter cube. That equal to 10 power minus 3 meter cube. 10 cube centimeter cube. And again 1 centimeter cube equal to 1 ml. Okay. So last one, very important. If examiner in exam given like this, how can you understand this representation? Simple. You have to remember, whenever we have W, in general we have to take W in grams. W in grams. And if you have the volume, you have to take in ml always. In most of the questions you have to take like this in general. Okay. And remember, X% W by W. So this is in grams, this is in grams. Here W by V, this is grams, this is ml. Here V by V, both are ml. Again, X% W by W. Here this X and this numerator W represent solute. Okay. And this percent, cent means 100, percent 100, and this W, this percent and W represent solution. Means this numerator W and X always represent solute, and this percent and this denominator W always represents solution. And again here, this X and this numerator solute, and this percent and volume represents solution. Here also X and this numerator volume represents solute, this percentage and volume represents solution. How can you write this? Simple. I have W by W. First, suppose you have 70 marks out of 100. Out of 100. That means you are getting 70 marks in 100 marks of the examination. In the same way, W by W means X grams of solute in 100 grams of solution. Okay, simple. Again, X grams of solute, because this is the grams, this is the ml. X grams of solute in 100 ml of solution. Okay, here X grams of, sorry, this is volume, so ml. So X ml of solute in 100 ml of solution. X ml of solute in 100 ml of solution. Okay, so you have to represent like this. Okay, so these are the important formulas and unit conversions in mole concept. If any other important formulas are there, definitely I will try to give them also in my next video. Okay, I will try to upload next video as early as possible. And that's all for this video. Thank you so much for watching, and please, if you haven't subscribed it, please subscribe, like and share. Okay, thank you so much. Take care. Bye bye.